Hello, my dear students. Welcome to my class on first class on vector. In today's class, we'll discuss about concept of unit vector. Okay, my dear students. What are physical quantities? Physical quantities are speed, velocity, acceleration, force, kinetic energy, potential energy, work done, torque, electric current, magnetic field. All these things are called physical quantities. Out of these physical quantities, there are some physical quantities which are vector quantities. So in today's class, we'll discuss about the vector. A physical quantity is called a vector quantity if it has magnitude as well as direction. You see, vector has magnitude as well as direction. Okay, my dear students, how to represent this vector in mathematical form? Let us see how to represent this vector in mathematical form. Okay, my dear students, let us see. Suppose I am writing vector as A. I am writing vector as A vector. It has got a magnitude part. Magnitude part is represented as only you write A. If you are putting a vector sign, then you give mod sign also. So either you write only A or mod of A vector. This is how we represent magnitude part. How to represent the direction part of A vector? What you have to do? Just write A, then give a arrow at the top. This represent, if you give a arrow at the top, it represents unit vector. Unit vector means it is a direction vector, means unit vector shows you direction, and this is the magnitude part. So vector has two parts. This vector has two parts. One is magnitude part, another is the direction part, and direction part is called unit vector, and it is also called direction vector. Why it is called unit vector? Because unit vector, it only shows the direction. It has magnitude 1. It has magnitude 1. That is why we call it unit vector. So a vector has magnitude part and a direction part. Direction part is called unit vector, and to represent direction part, suppose it is a vector, you write A, then put a arrow sign at the top. Okay, my dear students, or cap. We can say A cap. We can also say A cap. Okay, my dear students? Okay. It is accepted everywhere in the world. There are certain name of the directions which are accepted whole worldwide. What are those name of the directions? How to represent those directions in mathematical form? How to represent those directions? Let us see. Okay, my dear students, it is a three-dimensional space. This is called positive direction of x-axis. You have already read in your class 10 positive direction of x-axis. This is positive direction of y-axis, and this is positive direction of z-axis. The unit vector along positive direction of x-axis is represented as I cap. Okay, my dear students. Similarly, along y-axis, positive direction of y-axis, the unit vector is represented as j cap. Similarly, in positive direction of z-axis, unit vector is represented as k cap. Unit vector is represented as k cap. This is worldwide accepted. Everywhere the same notations are given for unit vector. Okay, my dear students? Okay. If you go along negative direction of x-axis, along negative direction of x-axis, the unit vector is minus I cap. If you go along negative direction of y-axis, the unit vector is represented as minus j cap. Similarly, if you go along negative direction of z-axis, the unit vector is minus k cap. So these are the unit vectors along positive direction of x-axis, negative direction of x-axis, positive direction of y-axis, negative direction of y-axis, positive direction of z-axis, and negative direction of z-axis. Okay, my dear students, then how to represent a complete vector? You see, what is the question? A person has traveled 5 meters along positive direction of x-axis. What is his displacement? My dear students, you know displacement is a vector quantity. So, if I write displacement as S vector, it has magnitude part and it has direction part. What is the magnitude? Magnitude is 5 meter. Magnitude is 5 meter. Along which direction it is going? This person is going along positive direction of x-axis. The unit vector along positive direction of x-axis is I cap. So this is the complete vector displacement, and you write unit here meter. You see, a vector has magnitude part and then direction part. Here the magnitude is 5 meter, as because this person is going along positive direction of x-axis, unit vector or direction along positive direction of x-axis is I cap. Therefore, I have written it 5 I cap meter. Similarly, a person has traveled 3 meter along negative direction x-axis. What is his displacement? My dear students, displacement S vector has two parts, magnitude part and direction part. Here magnitude is 3 meter and direction is negative x-axis. The unit vector along negative x-axis is minus I cap. So this is equal to minus 3 I cap meter. Minus 3 I cap meter. Similarly, here my dear students, a person has traveled 6 meter along positive direction of y-axis. What is his displacement? The displacement has two parts, magnitude part and direction part. Here the magnitude is 6 meter and the direction is positive direction of x-axis. Unit vector along positive direction of x-axis is j cap. Therefore, this is 6 j cap meter. Similarly, a person has traveled 2 meter along negative y-axis. What is his displacement? Again, this displacement has two parts, magnitude part and direction part. Here the magnitude is 2 meter, as because the person is going along negative direction of y-axis, the unit vector along negative direction of y-axis is minus j cap. So this becomes minus 2 j cap meter. Minus 2 j cap meter. Next, a person has traveled 7 meter along positive direction of z-axis. What is his displacement? Again, the displacement has two parts, magnitude part and direction part. Here the magnitude is 7 meter and the direction is along positive z-axis. Unit vector along positive z-axis is k cap. This is 7 k cap meter. Next question. A person has traveled 8 meter along negative z-axis. What is his displacement? Again, my dear students, displacement has two parts, magnitude part and direction part. Here the magnitude is 8 meter and the direction is minus k cap. So therefore, because unit vector along negative z-axis is minus k cap, this becomes minus 8 k cap meter. My dear students, in today's class, we have discussed about how to represent a vector mathematically. This will help you in physics as well as in mathematics. In this class, we'll discuss about how to add two vectors, how to write vector in a two-dimensional coordinate system, in a three-dimensional coordinate system. These things will be discussed in my next class. Till that time, bye-bye and Jai Jagannath.